Welcome to IBM 80/20 training, solving 80% of the problems with 20% of the knowledge. This is part two for LVM class. We left off on the we can say fourth slide, going over some of the concepts. We just completed going over this slide. Moving on to the next slide. Okay, let's see here. Logical volume consists of one or more logical partitions. Each logical partitions have at least one corresponding from physical partition logic. Basically, the logical partition and the physical partition will have the same size. Actually, logical partitions are just pointing to the physical partitions. You can have up to 3 copies of each logical partitions. Okay. In AIX, in the corporate world, typically we always mirror the root VG. But now with the virtualization, now that is done very infrequently. Typically, when you had typical LPAR configuration, or even a standalone, if you go even more back in the days, you would have HDisk 0, HDisk 1. Each server would have 2 physical disks, and that disk would be entirely root VG. First, the HDisk 0 would be the primary, HDisk 1 would be the secondary, and they would and if one failed, and the system would always have the second to fall back on. That was the mirroring capability, solution that they had. Now that we had virtualization, now that we have VIO servers, and the HDisk 0 and HDisk 1 and all the other HDisk, they're not physical disk anymore. Okay, they're not physical disk. They are LUNs. They are SAN storage. SAN storages are RAID 5, RAID 6, RAID 7, whatever they may be. So they're already highly available. Okay, they have a parity if one of them fails, and the rate is still the rate is still good, and you will have the server won't go down, and you will have no problem. So typically system you'll see nowadays, depending on where you work, you might see 2 disks if they're 2 physical disks. Okay, and each and they will have, one would be the primary, second other one would be this copy of it. If you have systems with VIO server, you will only typically see 1 disk with 2 paths, with 2 VIO servers having 2 paths, which would be the correct way of doing it. Okay, basically you can read through some of this information yourself. There is a VGDA, which keeps track of the information of the volume group, and it has the partition configuration information. So all the information is kept on the VGDA, which is in the beginning of the disk, and the information, of course, is copied on onto some of the other disks, and so that thus making having the redundancy it needed, and just in case if one disk does fail, there's still a VGDA descriptor area on the other disk, and that also makes it nice that you can use a disk or any disk in the volume group to import the disk, and it'll bring in all the disk at once. And we will talk about that a little bit later on. This keeps track of the status of the disk, the state of the partitions, and so forth and so forth. Uh, let's see. You know, I left this blank so that so that you can try to understand and try to see if you can explain. When I did the training class, I had the students come up to the PowerPoint projector and try to explain this section themselves, and see how well that they understand the concept of the LVM partitioning PPs, LPs, LVs, and so forth and so forth. So you can try to, maybe spend some time and see if you really understand and grasp the idea of what LVM is. Okay, so here are some of the stats. This is a little bit old for 5.3. I don't think there should be major changes between 6.1 or 7.1, which are the new releases currently. Um, there are a lot of differences, especially with VIO, but uh, but not a whole lot. It's AIX is already a very well operating system, very fine tuned. There isn't much changes that they're making enhancements more likely. So for a normal VG, a scalable VG, a big VG, these are the number of maximum LVs you can have. Maximum of PVs, excuse me, you can have. That means this is the maximum of physical disks that you can have on a VG. Okay, so there's a limit. Okay, so depending on what your needs are. Okay, if you're you need to know if you're gonna be continuously adding this to the file system, and there's growth, and there should be some capacity planning. If there isn't, it's actually, AIX is so good that you can convert a normal VG into a big VG if you need to get that extra amount of space, LV, or, PPs, or so forth and so forth that you might need. This is basically we spoke about this on that first slide when I described the picture that we had. A disk drive in a system is referred to as a disk drive. When it's added to a volume group, is considered a VG. All the information for there are in the /dev directory. You'll see two character devices, hdev, hdisk, and dev slash r disk, rhdisk. Let's see that on the server. So I do a slash minus l slash dev, and let me just go ahead and grep for hdisk. Okay, so here here are the disk. So these are the disk, and these are actually a block character. And this is the C represents a character file, and this is a block file. So these are not your typical files over here, and these numbers over here are very important. Okay, these numbers refer to as a major number and the minor number. Okay, and when you make these numbers are very useful in some other aspects when you're configuring Oracle ASM devices. These numbers are used to create more aliases pointing to it, where the Oracle ASM would use those aliases instead of the HDisk names. And each disk, when added to the volume group, has a PV ID. A PV LSPV. If you do LSPV, list physical volume, the PV ID is the unique identifier for each server. Okay, these are unique. These are based on the physical serial number that's burned on the disk. Okay, so here's an example of the command with several disks with the PV ID. Uh, if you need to ever set the PV ID, you can set the PV ID like this, setting chdev minus L, hdev 7 minus A, PV ID equals yes. If you need to clear it for some reason, there's an occasion you might need to. You'll find out when you need to. Every scenario is different. Every place is different. This is how you can clear the PV ID. Okay, so this is the output. If you go into, you can go into the details of, we just did an LSPV. Okay, LSPV didn't give us a whole lot of information other than that. If I do a LSPV and space the edge disk name, it gives us more additional information. Okay, so it gives similar information to how many PPs are on this disk, how many are free, how many are being used, and where are they located. Okay, and then this kind of tells you, what place is it, where is it being used. Okay, we'll talk about the location in a couple of more slides ahead. So I went through and explained each one. You can read through, pause it, and read through some of these. They're pretty self-explanatory. Um, let's see. Yeah, pretty much. Next slide. Over here, we did the same LSPV command, but with the -L option. Now it shows you what logical volumes are on this disk. And the reason we do this, we should do this, and we can do this, is that sometimes you need to remove, you need to, if this is not a root VG or maybe some other disk, you need to replace this disk, or if it's a physical disk. You need to remove this disk and you're adding another disk, or whatever the case might be. You can look at what's on this disk, and you can actually remove all the data off this disk and onto another disk with a command like migrate PV. Okay, that can move it. So this also tells you where the data is located. Okay, this is the distribution of the locations. Okay, there's the LP, here's a PP that of each, and this should be pretty much one to one. Okay, this is the platter of the disk. Okay, they're broken up into, 5 sections: outer edge, outer middle, inner middle, and the center, and the inner edge. Okay, and this kind of gives you an idea, if you look at the numbers, of where the data is going. Okay, and the numbers will represent, where the data is. So the best amount of data would be always be in the center. That's the most efficient place. And less efficient, and when you get closer to the inside, the data ends up being more compact, from what I understood is. Here's additional information. Another option with LSPV -M, and this gives you the list, location of where the LVs are located. If you ever need to figure out what to do, well, what data you need, what you need to move. Okay, this is where we're gonna stop for part two, and then we'll continue with the next with this LVM training course on the next part.